Hello and welcome to the C++ series on Windows networking. In this video, part 1, we'll go over initializing the Winsock library. The first thing that's needed here, as you can see I have a basic application up, is we need to include the Winsock2 header. There is another header, winsock, which is outdated and should not be used. Now we have WSA data as our first thing that we have to create before we can initialize anything. Now that we have our WSA data structure zeroed out, it's important that we call WSA startup. The first parameter is the version requested. If you're on Visual Studio, you get this nice Winsock version. If you're using GCC with like code blocks or something, you may not have that macro available. In that case, just use make word. Sorry, it's one word. Like that. 2, 2. This is exactly the same as Winsock version. But for my example, I'm going to use Winsock version, which is just make word 2, 2. And the WSA data, which will be filled out by the WSA startup. Another thing I would like to point out is in a lot of Windows programming, you will see far and near pointers. Those don't mean anything anymore. It's just a pointer now. So if you're ever looking, like if you ever go into code and you're looking at a pointer type and you see where it says far pointer, I'm going to have a problem finding it now because I want to point it out. Oh, yeah, like right here. This char far here. If we look up what far means nothing now. So far, it doesn't do anything. So just know that if you see far or near in your pointer declarations, far pointers were used in 16-bit Windows and they're not used anymore. They're outdated, and now the correct assumption is to assume that it's just a regular pointer. So let's get on with the video. WSA startup returns an int. With this startup result, we actually can get two things. So we'll go to the documentation. Documentation states that WSA startup takes two parameters and returns an int. The return value, if it's successful, will return 0. Otherwise, it returns an error code, not socket error like most of the other Winsock functions. So we have our available errors here that can be returned from this function. And it does say specifically, do not call WSA getLastError. It says it's not needed and should not be used. So just make sure that when you call this function, if it's not 0, that you need to go ahead and assume that you have an error, and you can do whatever your application needs to do. So for me, if startup result equals 0, or we'll say does not equal 0, we'll simply return 0. Or we can return 1, which is the same as exit failure. So now that we've guaranteed the WSA startup has been called, it needs to be followed up. Kind of like in C++ when you have a new, you need to follow it up with a delete. So we have WSA cleanup, which takes no parameters but also returns an int. To see what WSA cleanup returns, I've already included this and search for this. By the way, if you search up Winsock2 and then the function name, it should take you to Microsoft Learn. And the documentation on this stuff is really good. And up at top here, you can see it says return value, which is what we're interested in. The return value is 0 if it was successful. Otherwise, the value socket error is returned, and a specific error number can be retrieved by calling WSA getLastError. In a multi-threaded environment, WSA cleanup terminates Windows socket operations for all threads. So this is important to note, that you really only need to call WSA startup and WSA cleanup one time, and all the threads automatically get access. So this is something that should be done in like in main as one of the first things, and cleanup should be done as one of the last things. Now, with this being stated, what are the possible error codes? It's possible that WSA startup was not called, or that the network subsystem has failed. And since we're using Winsock 2.2, this error does not apply to us because this only applies to Windows sockets 1.1. Since we're going to assume that the network subsystem has failed, and if it does, it's probably a major error anyway, and the application really can't recover if you're using networking stuff, then this is the only one that matters to us, and this really isn't an error because this basically just says you didn't call startup. So we really can ignore this return value. So to ignore a return value, I would recommend, since in Visual Studio and most other modern compilers, this should be fully implemented. C++ 20 allows you to do this. It may be in 17, but I think it's in 20, to just call standard ignore, which is just basically a type that can take anything, and it just ignores the return value, and it prevents compiler warnings. So if you have a warning for ignoring a return value, you can use standard ignore and it works fine. So now we have a startup followed by a cleanup. Now if we run the program, what you'll see is right from the beginning, we get a couple of link errors. It can't find WSA startup or WSA cleanup. So when we're going to go to the linker and we're going to go to input, we're going to add this as a dependency and tell the linker where to locate this library at. So it's ws for winsock2 underscore 32.lib. Now, this may seem confusing at first as I'm running on a 64-bit platform, and 32 should generally be used for x86. However, winsock2 underscore 32, the 32 does mean 32-bit, but they use the same name for 64-bit, for the 64-bit version of the library. So this will compile just fine on both 64 and 32-bit. Just know that that is the library you need for both of your platforms. And now when we run it, everything works fine. You can see how it initialized. The return value is 0, so it reached the bottom of the code and it cleaned up. But what if, just for say, there was a return here? Or let's just say that there was an exception that was thrown. Well, in that case, WSA cleanup would not be called. And it's important that this gets called because the system does not know that you're done using it. Now, modern systems, I'm going to say Windows 7 and up. If you don't call WSA cleanup, I don't think it's the end of the world. I'm pretty sure Windows will handle this just fine. But it's not good practice, and you shouldn't leave the responsibility to Windows. It's your responsibility to clean up. So in order to clean up, I recommend creating an RAII type. And we'll just make this a class, and we'll call this Winsock2 library. Something like that, or just Winsock library, because, specifying exactly what version it is probably isn't that great. I'm going to make this final, saying you cannot inherit from this. You cannot derive from this. You cannot implement anything extra on this. So of course, like before, we need a WSA data member. And we'll just zero it out. The other thing we need is is initialized. The is initialized is not really necessary if you prevent copy and moves. Because if you throw an exception in a constructor, which we'll go over here in just a second. So we can simply take this code here, cut it, and paste it up there. This goes away because that's being stored elsewhere. And we'll give the address of our WSA data. If for some reason startup result fails, we want to throw an exception. So we need to include the standard exception library. And there's two exceptions I would recommend throwing here. The first one is a standard runtime error and just say failed to start up Winsock. So you could throw something as simple as that and the message gets through, everything is fine, except there's no way to return the actual error code. Well, thanks to C++, there is something called system error, which is another type of exception that actually inherits from runtime error. And in here, it can take an int as an error code, where we know we have a valid system error code, and then we simply pass in our category, which in this case is system category. This will give us reasonable error codes onto what happened. Now, we don't need this as initialized variable if all we're doing is constructing and destructing. Because as soon as this exception gets thrown, the stack goes up this way and this object becomes invalid. So everything going up gets cleaned up and this destructor for winsock does not get called. However, there is something else that needs to take place, and that is if you want to be able to move this to another thread, I don't see why you would want to, but we want to leave that option available. We need to set this to true, and you'll see why in just a second. As I have my destructor, if we were not copying or moving, right, since we're throwing an exception, simply calling std ignore WSA cleanup, this is a valid call. There's no need to check if it's initialized because the destructor will only be called if the object's in a valid state, which by definition, throwing a constructor from here, the object cannot finish its construction. We can now get rid of these. And we are going to call winsock library, and we'll just call this winsock. Now, if I run this code, you'll see the exact same thing happens. And just so you know that cleanup and so startup has been called, cleanup has been called. So now, if I return, it doesn't matter where I return, if an exception is thrown, that destructor gets called and it gets cleaned up automatically. But if there was really an error, since we're throwing an exception, this goes out the window. You don't really need this and you don't need a check here. The only problem is we're going to implement a move. So we have to check if it is initialized, then we want to clean up. Copies are dangerous in these things because we're sharing a single state of is initialized. So to disable copying, there's there are two functions or methods, member functions that you need to get rid of, whatever wording you want to use here. It is important that you delete both the winsock copy constructor and the winsock copy assignment operator here. And you just simply declare them. They need to be const the type reference and then just make it equal delete. That prevents all copying of your object. And then to get some move, all we need to do here is we simply just need to, we can't move our is initialized. So what we need to do instead is we need to call this std exchange function. And what std exchange does is it takes in a value and you give it a value to set the value you passed in to. So in this case, is initialized is what's going to be returned, and is initialized is going to be set to false. This prevents accidental mishaps. So this way, if I send this over to another thread, if the other thread ends early, it's going to clean up. So if I set that is initialized to false, that thread cannot clean up. So now we just need our WSA data, and we're simply going to make that equal lib MWSA data. That's our move constructor. And now we need our move assignment operator. And for this, it's not a constructor, so you can't initialize the values like you want to. So for this, there's two ways to do this. The first thing you could do is you could make a copy and then move it over. But in my case, this right here is going to work just fine. We're going to set is initialized equal to standard exchange. Right hand side is initialized, and we'll set that to false. And then MWSA data, right hand side dot MWSA data, and simply return pointer this. And since again we're not constructing them, we have to just move the memory over. So now we have our constructors, destructors, none of which throw exceptions except for the constructor. But what if, for some odd reason, you really cannot risk throwing an exception? I never recommend getting rid of exception handling. Instead, what I recommend doing is providing an opt-in no-except constructor. This is how that is done. Create an explicit constructor that will take one argument, because in this case, this takes no arguments. And we're going to do std no throw underscore t. Now we can mark this function as no except. We can copy this function. And instead of throwing an exception here, we simply return. And M is initialized never gets set. And now we can have a couple of functions here. Bool is initialized. We can have an explicit operator bool. M is initialized. And you'll see what that one is here in a second. Const WSA data. Get WSA data. So now we have a way to get the data, and we have a way to get whether or not it is initialized. The destructor is going to work correctly. We have some move assignment operators. And now the only thing that will throw an exception is this. But if for some reason you don't want to, you can call this function here, and I'll show you exactly how to call it. So the way you call it is, right now we're opted into the exception thrown function. So if winsock fails to initialize, a system error gets thrown. But if you don't want that, then what you can do is you can actually do no throw. And now the function that's getting called is actually this one with no throw t. And this guarantees, this is like a standard way to have a opt-in no except method. So now, if for any reason this does not work, you now have to check it, but maybe this is exactly what you want. So if not winsock, then we can return 1. And just to kind of show you what's going to go on here, we can create a const expr. Nah. Let's not do that. Let's just do it here. I'm going to create something with 0. And now it should return 1 because an invalid state was called. And you can see no exception got thrown, so it's calling this function. But if I were to do this one, get rid of the no throw, this check becomes unnecessary because it's only going to be constructed in a valid state. Oh, and of course, 1 is valid. I don't know why I didn't put 0. So now an exception will be thrown because startup failed. And just to kind of see the power of system error, since we're on the subject, I want to try to initialize this, and then I want to catch the system error, and I'm going to print out error.what. And what you'll see is you get a clear error code of basically what's happening. The Windows socket version requested is not supported. So you get really good error reporting with system error. So now for us, we're going to use no throw and then simply check. If not winsock, return 0 or return exit failure. And then we need to make sure these are winsock version again. So now we have this opt-in constructor that does not throw an exception. We have all the functionality that we need here. The only thing that's missing is we probably are going to want to inline all of these functions to tell the compiler, hey, you probably want to inline most of these. And yes, you can even inline constructors and destructors. Again, this isn't a guarantee that they'll be inline, but it is a hint to the compiler that, hey, I really would like these to be inlined. And so now what we have is we have this. So what we have here is we have this type that now I want to move. It's up to you. You can make this header only, but all this stuff would have to be included. We can throw this in a module. But what I will do instead is I will simply provide all of this code here in the description of the video. And you can copy and paste and refactor this however you would like. But this is a simple RAII type that allows you to initialize winsock, and you don't have to worry about the startup and cleanup versions. If you simply, but however, just remember, you do need these headers. So you will need system error and you will need winsock2. So if you want header only, you can do that. You would just need to wrap it inside of a, you would need to include these headers for your stuff to work correctly. All right, anyway, that is initialization to winsock. So after this, you're on your way. This does allow you to initialize winsock without a problem. And now you can go on and you can start your networking code. So in the next video, what we'll do is we will create a simple socket. And we'll go over some of the function parameters used to create sockets. And then we'll wrap that socket in an RAII type. Anyway, y'all have a good one. Look forward to the next video. Bye.